Hello, beautifuls. This is Atleen, and I'm going to do another video. So let's take a look at subnetting. Previously, we discussed the fact that we have a default subnet mask for all of our different classes of addresses, but that's not always sufficient. Matter of fact, it most likely won't be sufficient. What we can do instead is alter the subnet mask. Let's say that I'm using a Class B network and I have 172.16.0.0/16, which is a private address. Well, maybe I'm using it in our huge company, and we could put everyone in this network not going through any routers, and they will be part of the same huge broadcast domain that doesn't seem efficient, and we're going to have 65,000 of them in there. So what I most likely wish to do is, as a designer, instead is keep engineering separate from accounting, and keep human resources separate, keep them separate from human resources, and so on. So we have them in their own broadcast domains, their own spaces, which will help with security as well. And we could place security filters on the routers. So it's a great idea oftentimes to take a network and add bits. That's the keyword, add bits, keywords, add bits to the subnet. To the subnet mask. We're going to add ones, making the number of ones higher. So instead of having a 16 subnet mask, maybe we will have a 24 subnet mask. We added 8 bits. And by doing this, it's going to give us more subnets, more broadcast domains, more networks. As we create more subnets, we're taking away the maximum number of hosts. The number of hosts that we can have in a subnet. Like, for example, on the paper, we're just interconnecting 2 buildings. On the bottom, those are buildings. Site to site, point to point. If I use Class C address for that, which is 254, Class C 254, it is 254 usable IP addresses in the Class C network. If I'm using a Class C network for that, I only need 2 addresses, one for one side and one for the other. And it's a good idea to optimize our subnet mask. So here's another reason why we may want to manipulate that subnet mask. Looking at the example, let's say that our router has a ton of route entries that is trying to store, is overwhelmed. Multi-layer switches also, they may have many entries, and we don't want them to have many entries, or we don't want them to advertise that much to their neighbors, because that's a great deal of traffic. So we don't really want to advertise too much. So what if we took a bunch of networks that have a lot in common, like the one in the example? We have 192.168.1.0, 192.168.14.0/24, 192.168.25.0/24, and lastly, 192.168.30.0/24. So with these four networks, instead of advertising those individually with our routing protocol saying here's this one, here's that one. If we look at this in binary, we know that the first octet is going to be the same. 192, 192, 192, 192. Well, the first octet is 192. And the second octet is 168. And the third octet, we might have some bits, as you can see. The third octet, because they are not the same. It's 1, 14, 25, and 30. There will be differences, but let's see if we have any bits in common. If we write those numbers in binary in the octet, we'll see that first three bits are zeros. And all four of those numbers, so all four of those networks, they've got the first 19 bits in common. Okay, so I'm going to stop here. This is part 1, and we'll do part 2 tomorrow. Thank you for watching, and I wish you well.